All right, a geometric sequence is a sequence where successive terms, or each term, is a multiple of the one before. So a common ratio or multiplier. So 4 times 3 is 12, and 12 times 3 is 36, so the ratio is 3. The next one, you multiply the first term by -2 to get 4, and then -8, and then 16. Or you can think of it as dividing, but really it's a ratio. So instead of dividing by 5, humans usually think dividing by 5, but just in a calculator, you're multiplying by 1/5. That's the multiplier. So it's always a ratio or a multiplier. The general term for Tn is the first term A, right? That's T1, times r to the n minus 1. And of course, the exponent comes first in BEDMAS. So n minus 1, you have to do n minus 1 first, and then apply the exponent to r, and then multiply by a. For each of the following, find Tn and T7. So a is 4, r is 3. So Tn is a r n minus 1. So this is Tn is 4 times 3 to the n minus 1. Okay. And for T7, we have 4 times 3 to the 7 minus 1. So that's 3 to the 6. So our total for the final answer is 2916. So here are the two answers we were asked for. Go ahead and do the next two. Pause the video. A is -2. R is -2. So Tn is -2 times -2 to the n minus 1. T to the 7 then is -2. -2 to the 7 minus 1, which is 6. -128. And then the third one, A is 25. R is 1/5. Tn then is 25 times 1/5 to the n minus 1. T to the 7 is 25 times 1/5 to the 7 minus 1, or 6. So that'll be 1 over 625, or 0.0016. Two answers were asked for, Tn and T7. Number 2, determine whether the sequence is geometric. To do this, what we do is we find a few terms and then see if there's a common multiplier. So T1, we're given as 10. T2, 3 times 10 minus 5 is 25. T3, 3 times 25 minus 5 is 70. T4 is 3 times 70 minus 5. That's 205. So T2 over T1 is 25 over 10, 2.5 or 5 halves. T3 over T2 is 70 over 25, and that is 2.8. And T4 over T3 is 205 over 70, 2.92. There is no common ratio. So this sequence is not geometric. Okay. Example 3. Find AR and Tn. So given T2 is 10 and T9 is 781,250. Remember, Tn is a to the rn minus 1. So when n is 2, T2 is 10 is equal to a to the r, and n is 2. So that's r to the 2 minus 1. So we have 10 is equal to a times r. When n is 9, we have T9 given as 781,250. AR to the n9 minus 1, n minus 1. So we have 78,1,250 AR to the 10. We'll number the equations up, so equation 1 and 2. We'll take equation 2 and divide by equation 1. So we have 78,125. The a over a reduces to 1, r to the ninth. The ninth root of 78,125 is 5. Okay, so we have r, that's the first thing we found. Sub r equals 5 into equation 1. Get 10 is equal to a times 5, so a is equal to 2. So there's the second thing we were asked to find. And then finally, using these two things, we are going to find Tn. So we have 2 times 5 n minus 1, and that's Tn. And finally, the fourth example, a radioactive material reduces 15% by 15% every year. So at the start, so times 0, we have 100 grams. At 1 year, we'll have how much? Well, 15% less, 15 grams less, 85. In 2 years, well, we're multiplying by what? What do we have to multiply? Well, not by 15, because then we have to do a subtracting step. Well, it's 1 minus 0.15 or 0.85. So that's the R value. We're multiplying by 0.85, and I'll get the value here. Let me just grab my calculator. 85 times 0.85 is 72.25. We could keep going for 15 years, but that's a lot of work. The initial value is not 100 grams. It is the first value after 1 year, so it's 85 grams. So Tn, A times R, the n minus 1, Tn is 85 times 0.85 n minus 1, and then we want T15. So the exponent will be 14. We end up with 8.74. After 15 years, there is 8.74 grams remaining. And that's it for the video.